Welcome to our physics classroom. Good day, everyone. I hope you are doing fine and you are now done with the learning activities that I've assigned you last week. In our today's lesson, it has something to do with the picture that you've seen in this illustration. As you can see, we have here a clock. So the hands of the clock is moving. For us to be able to explain the movement of these hands in the clock is we need to understand our lesson for today, and that is periodic motion. Before we proceed with periodic motion, it is necessary for us to review your knowledge about parts of the wave. So let us start. Okay, let's say we have here a transverse wave. I will use this illustration to give you the different parts of the wave or to review your knowledge. So we have the equilibrium. The equilibrium is this line, or that is the stable part of the wave. And then we have the crest. So that is the highest point of the wave. So this is the crest, this is also the crest, and this is also the crest. And on the other hand, the lowest point of the wave is what we called trap. So this is trap, and this is also trap. Okay, the distance between the crest to the equilibrium, so the distance or displacement between the crest and the equilibrium is what we call the amplitude. Here we also have the amplitude on the lower part of the wave. So we also have amplitude and amplitude here. The distance from crest to another crest is the wavelength. So that is the part of the wave. It is very important later you will use this one in understanding our lesson for today, which is periodic motion. Now let us proceed defining the periodic motion. So periodic motion refers to the motion that is repeated at regular interval of time. So we're talking about the motion here. If the motion of the object is repeated at a regular interval of time, so we call it as periodic motion. For you to understand what is periodic motion, let us have an example. So example of periodic motion, we have rotation of blades in an electric fan. So the blades in an electric fan, as you can see in this example, moves in an interval manner. So it follows an interval pattern. Same with rotation of the earth. So it follows a time interval. So that is repeated movement of the earth. If we include rotation of the earth as example of periodic motion, of course, the movement of the earth around the sun is also, or the revolution is also an example of periodic motion. Another example of periodic motion is the hands of the clock. Okay. Another one is the pendulum in grandfather clock. So this one is an example of a grandfather clock. So the periodic motion in this example is the pendulum here. So this pendulum moves in a regular repetitive interval manner. So it has a pattern, no, of movement. So it also considered as periodic motion. Another is a rocking chair. So you are familiar with this one. This one is the movement of this one is also an example of periodic motion. And as well as our heartbeat. So the way on how our heart beat consider as the periodic motion. Okay, so in periodic motion, we have to remember that we have this called equilibrium position or resting position. So later on, we will define what is this equilibrium position. You just have to remember that when a body moves in periodic motion, it has an equilibrium position or resting position. So let us define this term. So equilibrium or resting position is a position assumed by the body when it is not vibrating. So let's say an object is moving in periodic motion. So there is a part or position where the object experiences that it will not vibrate, no? So when the object is not vibrating, meaning the object reaches its equilibrium position. For you to visualize what is equilibrium position or resting position, let us have an example. So imagine we have here a girl in a swing, no? So let us write the position or illustrate the position of this girl in a swing. So this will be look like this. So we have the position A, position B, and position C as the girl is swinging on the swing. So as you can see, the position B is what we call the equilibrium position. A while ago, it was defined that the equilibrium position or resting position is the position of the object when it is not vibrating. So, dun sa example natin, if that girl is moving in this direction from A, B to C, no, and back and forth, so pag nare-reach niya to equilibrium position, the object will not vibrate. Or kaya nga tinawag natin siya as resting position. Now, let us explain the periodic motion in a swing. So, bakit nga ba yung swing ay nagbe-behave in periodic motion or in a regular interval manner? So, let's say we have here the illustration. We know that this position is the equilibrium position. So, pag nare-reach niya yung part na yan, it will rest for at some moment, saglit lang. No? So, when the girl moves from equilibrium B to position A, so let's put an arrow. Sabi dyan, when this girl move from the resting position going to position A, what will happen? The force or the restoring force, in this case, the restoring force is the force of gravity, act on it to pull it backward towards the equilibrium position, which is true. Kapag nagduduyan kayo, na-experience nyo yan. From equilibrium position, mag-move siya dito, then the force of gravity will move it back to its original equilibrium position. So that force of gravity in this case is the restoring force. In a periodic motion, we have this called restoring force. In this case, restoring force is a force that tends to restore a body from its displacement to equilibrium position. Madali lang naman intindihin pag sinabing restoring force. From the word restoring, no? This force is the force that will restore this object back to its equilibrium position. So, bakit mag-move siya ulit papunta naman sa C? This is the reason. So, let's say, again, the object move from B to A. Then, because of the restoring force, babalik siya sa equilibrium position. No? Pag na-reach niya na ulit yung equilibrium position, pag nandyan na siya, no, yung girl natin in this position will gain kinetic energy. Okay, so from B to A, then because of the restoring force, babalik siya to position B. That time, this object will gain kinetic energy. And then, it will move somewhere along this position C. So, kapag nasa position C naman siya, again, at in this position, makaka-experience na naman siya ng restoring force. Hihilahin na naman siya pabalik doon sa equilibrium position. So, ganun lang din mangyayari. And then, mag-gain siya ng kinetic energy. And then, mag-move ulit siya papunta dito sa position A. And then, yung restoring force again, it will move this object back to its resting position. Kasi yung ating restoring force, ang role niya is to move the object on its equilibrium position. So, pero pag nasa equilibrium position siya, the object will gain kinetic energy. Kaya magmumove naman siya on another side. Ganun yung nangyayari. That's why nagkakaroon ng periodic motion in a swing. So, same with the pendulum. Let's say we have here a pendulum. So this one is a bob and we have here the string. So we know that the pendulum moves in different position. So let's say we have A, B, and C. So this one is the equilibrium position. Again, when the bob moves from equilibrium B to position A, so this one, the bob will experience the restoring force. no? Pag nagkaroon ng restoring force, no, this restoring force will tends to restore the body or this bulb to its original position, which is the equilibrium point. At this point, pumunta siya sa B to A, then because of the restoring point, it will move from A to B. Then this point naman, nandito siya, the bulb will gain kinetic energy. For at some moment, hihinto siya saglit lang. After gaining the kinetic energy, it will move again to position C. And then, dito sa position C, magkakaroon ulit ng restoring force. And that restoring force will be the force that will pull it back towards the equilibrium position. Mag-gain na naman siya ng kinetic energy, then it will move to position A. Then, restoring force, ganun lang yung nangyayari kung bakit nagkakaroon ng movement or bakit may periodic motion in a pendulum. As simple as that. Okay. So as you can see from the explanation, we can say that the vibration about the equilibrium position is a result only from the restoring force. Okay, so that restoring force will be the force that tend to move the object from the displacement towards the equilibrium position. As simple as that. Okay, now let us understand these things to remember, which are very important to understand our lesson for today. Okay. So we have amplitude, period, and frequency. Okay, let's start with the amplitude. The amplitude of vibration is the maximum displacement of a body from its equilibrium position. So we already discussed what is equilibrium position. So you have to remember that when we say amplitude, we are talking about the displacement from the equilibrium position to the maximum displacement. So to illustrate that, I have here a simple illustration. So let's say we have here a wave. A while ago in our review, I've shown you the meaning for the amplitude. So this is the distance between the highest position or the crest to the equilibrium position. So this displacement is what we call the amplitude. So let us illustrate it more for you to understand. So let's say I have here a pendulum. So as the pendulum moves, you can see in this illustration that it forms a wave motion. So let us again post the definition for amplitude. Okay. So for you to understand it more, let's say I will get this wave motion into picture. It will be look like this, or let's say this one is the string. So the movement of the string will be like this one. Okay. So from this picture, we will define the amplitude. So sabi dyan, that is vibration from the maximum displacement. So in this example, here is the maximum displacement sa ating crest. And then, from its equilibrium position, so this one is the equilibrium position. Okay, so the distance between this one is what we call the amplitude. So, as simple as that. Now, let us proceed with period T. So, in solving problem, we will use the symbol T for the period because we are referring to time in this topic. Okay, so let us define period. Period is the time, as what I said a while ago, time required for one complete vibration. For example, from one crest to next crest. So, yung one complete vibration, that is crest to crest or trap to trap. Okay. So, you just have to remember, period, we are referring here the time. So, ang tanong dyan, gaano katagal bago niya makomplete yung isang cycle or vibration. So, we have a formula to calculate the value of our time. So that is T is equal to 1 over F. So in this formula, T is the period and then F is the frequency. So as simple as that. As you can see, uh, period is the reciprocal of the frequency. Okay. So the unit for period is seconds, since we define period as the time it takes to complete the one cycle or complete vibration. So for frequency, we will use this italized F as the symbol for frequency in solving problem. So let us define frequency. Frequency represent the numbers of vibration per second. So kaya nga 'di ba pag sinabi nating frequency, how frequent? Gaano kadalas, no? So that is vibration per second, or we can say cycle per second or time per second. Again, the frequency F is the reciprocal of the pendulum's period. That's why the formula to get the value of frequency is 1 over T. So that is reciprocal of period, where F is the frequency and T is the period. The units for frequency is cycle per seconds or hertz. Here is the formula for period and frequency. As you can see in the problem, the period and the frequency are inversely related to one another. Meaning, so dito pala makikita natin na nasa numerator, ito nasa denominator. So as this quantity increase, this frequency decrease. Same with this formula. And obviously, upon looking on this equation, you will tell that they are reciprocal of one another. So period is reciprocal of frequency and frequency is reciprocal of period. Sometimes, instead of the frequency, angular frequency is used. The symbol for angular frequency is omega. So we call this symbol as omega. So para siyang small w. So let us identify the equation for angular frequency. So we have omega is equal to 2 pi multiplied to the f if the frequency is given. And another one, we have omega is equal to 2 pi over t if the period is given. So pag frequency ang given, to find the angular frequency, we will use this formula. And if the period is given, to find the angular frequency, we will use this formula. So it is important to remember this conversion when we are dealing with angular frequency, which is 2 pi radian is equal to 360 degrees. So later on, we will use this conversion sa ating solution. You have to remember this one. Okay, let us solve problem about our lesson, which is periodic motion. And we will use those formula that we've discussed a while ago. So you have to ready your things, your calculator, your paper or scratch, and your pen. Here is the first problem. Okay, so if you want to answer it first, you may pause the video and then try to answer this problem. And if you have the answer, you may play it back. Okay, let's start. Let us read it first. A girl fly flaps that swing back and forth 121 times each second. The period of the wing flapping will be, so that is the problem. So we have to find the given, the required, the equation, the solution, and the answer. From the problem, the given is 121 times each second. So let us put this given to this side. So that is the value of the frequency. So 121 cycle per seconds. As you can see, instead of putting time, I use cycle per second to indicate that is the frequency. So gaano ba kadalas? That is 121 cycle per second. So the required in this case is the period. So just put it here. T is equal to question mark. So again, the formula for period is T is equal to 1 over F. So that is the reciprocal of frequency. So the solution will be 1 over 1 cycle over 1 to 121 cycle per second. So as you can see, nilagyan ko siya ng cycle dito para makita natin na ito ay maka-cancel, no? So let us cancel this cycle. So doing the math, the answer is 0.00826 seconds. So I hope you have the same answer with me, and it is very easy. Now, let us proceed with the second problem. If you want to answer this one, so here is the problem. Again, you may pause the video and then try to answer this problem. Okay, let's start. So, what will be the given, the required equation, solution, and the answer? From the from the problem, again, the given is 2 seconds. So, that is the value of the period. So, write it here. And another one, the question is frequency. So we need to find the frequency. So we have this f is equal to question mark. The equation is the reciprocal of period. F is equal to 1 over t. So the solution, we have 1 over the period, which is 2 seconds. So the frequency is 0.05 cycle per second or 0.05 hertz. So you may use this unit or this unit. I hope you have the same answer with me, and it is very easy. Okay, let us have another problem. Suppose that we're going to calculate the frequency of an oscillating object with a time period of 30 seconds. So we have the given, required, equation, solution, and the answer. As you can see in the problem, it was given here the period. So that is 30 seconds. So let us put it here. And then the required is the angular frequency. And we know that the symbol for angular frequency is omega. So omega question mark. And the formula for angular frequency when the given is t, or when the period is given, so that is omega is equal to 2 pi over t. So pag yung frequency, yung 2 pi frequency. Pero in this case, the given is period. So napakadali lang ng problem na to because we only need one given, which is the value of period. So we can now proceed with the solution. So ang omega is equal to 2 pi over the value of period, which is 30 seconds. So kanina, I give you the conversion that 2 pi is equal to 360. So pwede nating isolve yung problem, another solution lang. Or pwede na rin to, kaya lang pwede rin nating i-convert itong 2 pi, and sabi ko kanina, 2 pi is equivalent to 360 degrees. So we will put it here. So that is 360 degrees over 30 seconds. So pwedeng ito yung solution mo or pwedeng ito. Kaya lang magkaiba sila ng unit. Kapag ito yung ginamit mo, this will be rad per second. Pag itong ginamit mo, this will be degree per second. So for this solution, the answer will be 0.209 rad per seconds. Kapag ito naman, ang answer mo will be 12 degree per second. So ito mga anak, pareho lang sila ng value. Pag kinonvert mo ito into rad per second, this will be 0.209 rad per second. Kung ito naman ay kinonvert ko into degrees, ito naman ang kanya magiging value. So, let us have the conversion. Let's say, ko-convert ko ito into degrees. So, we have 0.209 rad per second, and the conversion factor is, in 180 degrees, we have 1 pi, and that is the radian. So, if you use this one, the value will be 12 degrees per second. Same with this one. So, kahit ano dito, will be your final answer. So that is the value of our frequency for this problem, given that the period is equal to 30 seconds. Since we're done with periodic motion, let us proceed with type of periodic motion. One of the type of periodic motion is simple harmonic motion. So what is simple harmonic motion? Let us define this one. So, simple harmonic motion, it is a type of periodic motion where the restoring force is proportional from its equilibrium position. So, we know that in periodic motion, we have this term called restoring force. So, sa simple harmonic motion daw, it is a type of periodic motion na kung saan yung ating restoring force is proportional from its equilibrium position. To understand simple harmonic motion, let us have a sample, and that is spring mass system. So, this is one of the best example for simple harmonic motion. Let's say we have here a spring, and then we have here an object that has a mass. Because of the mass of the object, the spring will vibrate. The vibration of the spring will form a wave. So as you can see, this is to show the vibration of this spring mass system. So, and that vibration will be an example of simple harmonic motion. Another example of simple harmonic motion is the movement of the hands in the clock. No, hands in the clock. So, as the movements of the hands in the clock, it will also create a simple harmonic motion. So, simple harmonic motion, again, it is a type of periodic motion. Huwag malilito. Na kung saan yung ating restoring force is proportional from its equilibrium position. From the definition, we can create the formula. So, sabi dyan, force, so let's say we have Fs. So, that is restoring force. No? It is different from the external force, ha? Restoring force is the force needed to move the object on its equilibrium position. Kaya nga siya tinawag na restoring force. Kasi it will restore the position of the object. Sabi dyan, the restoring force, let's say we have Fs, is what? Proportional to equilibrium position. So this is the equilibrium position or the displacement. In this simple harmonic motion, we have this called K. So that is the constant proportionality. So itong K na to, it indicates na kapag maliit ang value niya, yung spring mas madali siyang stretch or i-compress. Pero pag malaki ang value ng ating K, ibig sabihin, ang spring is mahirap i-stretch or i-compress. So this K is also known as the constant force. So for you to understand the equation easily, so let us define each term. So Fs is the restoring force. Restoring force is the force needed to move it back on its equilibrium position. So X is the displacement, no? Ito yung movement ng ating spring kapag siya ay na-stretch or na-compress. And then, K is the proportionality constant or that is the constant force. Ang unit ng ating K is Newton per meter. Again, tandaan, the unit of our K would be Newton per meter. And we call it K as constant force. Itong Fs, that is the restoring force. Okay, so in the simple harmonic motion, the formula for to get the restoring force is negative K multiplied by the displacement. Bakit po negative? Because in simple harmonic motion, the negative sign indicates that the restoring force and the displacement x are in opposite direction. So kung ang ating force daw ay pakanan, no, yung ating displacement naman pakaliwa. So kapag ang displacement naman ay going right, no, ang ating force naman ay left. So to denote the direction of that, the formula will have a negative sign. So let us explain it more on the next slide. For you to understand how the restoring force, Fs, and the equilibrium displacement is x are in opposite direction, let us have an illustration. So let's say I have here spring that is not stretch nor compress. So kapag yung spring natin is ganyan, so hindi siya naka-compress, hindi siya naka-stretch, so siya ay nasa equilibrium position or at rest. Let's say I stretch this spring using this object. So this object since meron siyang mass, exert a force to stretch the spring. Ngayon, we need the restoring force para mabalik siya sa kanyang position. So, let us denote here the restoring force. Ang direction ng ating restoring force to move it back on equilibrium position will be going left. So, in this case, the value of our Fx or restoring force will be negative. You have to remember that when the spring is stretched, ang ating x, syempre pag ganun ang movement niyan. So, that is moving right. So, that is positive kapag naka-stretch. Siyempre, yung spring natin, mag-move siya in right direction. So, as you can see, this one, magka-opposite na sila ng direction. So, ito, moving towards left, yun ang direction ng ating force. No, ito naman ang ating displacement. Remember, restoring force is different from the force na in-exert nitong ating mass. Restoring force is the force that tends to restore to its equilibrium position. So, kailangan niya itulak pa ganun yan. Kaya ganyan ang kanyang direction. Para mas maintindihan, let us have another example. So, let us have a compressed spring. So, let's say, kinompress natin yung spring. This mass compress the spring. In this case, kapag kinompress natin yan, no, the value of our x or displacement will be in this direction. Kasi nga pa-compress. Kapag stretch, ito ang direction. Kapag compress, this one is direction. So, the value of our x would be negative. Ngayon, the restoring force needed para maibalik siya sa equilibrium position niya, no, the direction will be in this. So, patulak naman siya. So, in this case, since pa-right ang ating restoring force, this will be positive. As you can see in this example, it is always opposite. The Fs and the displacement are in opposite direction. Kahit sa compress and stretch, opposite direction siya. That is the reason why the formula has a negative sign to denote that the restoring force and the displacement x are in opposite direction as shown in the illustration. So again, how about the external force? Kanina, we described the restoring force. Restoring force is different from external force. So when we say external force, that is the force required to stretch or compress the spring. So kung bakit nagko-compress yung spring? Bakit siya nag-i-stretch? No? That force is not the restoring force. That force is the external force. So let us clear it more. So these are the things you remember para hindi ka malito. First, you have to remember that external force. So let us use Fe to denote that is external force. External force and restoring force, Fs. So nilagyan ko siya ng S to denote that that is the force of the spring to restore itself from equilibrium position. So they are different. Okay. So paano nga ba sila nagkaiba? Ano ba yung external force? External force is the force applied to stretch or compress the spring. So bakit nagko-compress at nag-stretch ang spring? Because of the external force. On the other hand, restoring force is the force that tends the body to restore in equilibrium position. Madali lang tandaan. Kaya nga, it is called as restoring force kasi nga, this force restore the position of the spring sa equilibrium position niya. So, wag malilito dito sa dalawa. Later on, we will give equation for external force. So, let's say in this example, gamitin natin yung kanina sa illustration. No? So, we have here the restoring force. Ang direction niya is pa ganun para bumalik siya. And that is negative. The displacement is in this direction kapag stretch. That is in the right direction. So, that is positive. So, in this case, yung external force or yung force exerted by this mass, no, it is obvious na kaya nga siya nag-stretch because ang ating force is in this direction. So, makikita pa lang dito sa illustration natin that the restoring force and the external force are in opposite direction. Lagi yon. Lagi silang magka-opposite ng direction. Ito namang restoring force at saka yung ating displacement, lagi din sila magka-opposite direction. Pero, pansinin nyo, in this case, so yung Fe natin positive. Pareho silang positive kasi yung ating external force tsaka displacement is pareho sila ng direction. Kasi nga, to stretch the spring, so yung force mo i-apply pa ganon. So, ang magiging movement niya is pa ganon din. So, lagi silang same ng direction. Ito, lagi magka-opposite. So, another example sa compress. Let's say, inompress ko tong spring. So, yung ating restoring force para bumalik siya to its original position is in this direction. And that is positive. The displacement naman, dahil compress siya, so, ang magiging displacement na ating spring will be in this direction. So, opposite. Sabi ko nga sa inyo, yung ating x is same direction siya sa ating compressed spring. Ngayon, itutulak to ng ating object here. So, ang direction ng force nitong object na to will be, that is the external force, and direction will be in this case. So, pansinin, Fe and x are same direction. Fe and x here are in same direction. But these two are always opposite. Always opposite. So, huwag malilito dyan. So, mula dyan, so that is also negative. Mula dyan, we can now give the formula for external force. So, ang formula for external force, same lang siya with the restoring force. Ang magkaiba lang, dito, positive. Bakit po naging positive, ma'am? Kanina, ang formula ng ating restoring force may negative dito. Kasi ang hinahanap ay restoring force. If ang hinahanap natin is the force needed to stretch or the force needed to compress the spring, that is external force. Wala tayong sign na negative here. Kasi dun sa illustration, makikita nyo that the external force and the displacement are always in same direction. So, kapag ang i-compute ay external force, we don't need to put negative here. Okay, so that is positive. So, as you can see, yung ating external force and restoring force, same sila ng value. Pero magka-opposite sila ng direction. You just have to remember that one. Okay, equal value, opposite direction. Okay, how about the equation for period and frequency of a simple harmonic motion? So, in this case, it is different because we are dealing with simple harmonic motion. So, as you can see, it was given or it was defined that the simple harmonic motion, the restoring force, and the equilibrium position are proportional to one another. So, the formula for period and frequency will be quite different. In order to get the period of simple harmonic motion, the formula that we're going to use is this one. So, that is 2 pi square root of m over k. So, t is the period or the time it takes for one cycle. M is the mass of the object. Let's say in the spring, that is the mass of the object on the spring. And K, that is the constant force. And the unit for that constant force is in Newton per meter. So, this is the formula to get the period of simple harmonic motion. And to get the frequency of simple harmonic motion, the formula will be this one. F is equal to 1 over 2 pi, so that is the reciprocal of the period, square root of K over M. So, F is the frequency, M is the mass of the object, or let's say in the spring, that is the mass of the object on the spring. And K again is the constant force that is in Newton per meter. So that is the equation to get the frequency of a simple harmonic motion. Now let us proceed with the calculation. You have to ready your pen, your calculator, and your paper before we proceed with the last part of the lesson, which is the solution. So, here is the last problem. Suppose that a 2.5 kilogram object is suspended from a spring, and then the spring stretched by 0.05 meter. So, the question is, what is the force constant or the constant force K? B, if the mass set into vibration, what will be its frequency? So, if you want to try to solve the problem with yourself, you may now solve it. If you are quite unsure, so you just have to follow my solution for you to understand it more. So, let's start. So, the given in the problem, the required, the equation, the solution, and the answer. So, let's start with the given. The given on the problem, we have 2.5 kilogram, and that is the value of our mass. So, let us put it here. And then, we have 0.05 meter. So, that is the value of our x. And as you can see, we have A, B, C, A, N, sorry, A, N, V. So, the required for this one is the force constant and the frequency. So, dalawa. So, sa required natin, lalagyan natin ng A and V. A for the force constant or the value of the K. And we have the V for the frequency. Okay. Since dalawa yung required natin, yung equation natin, it must be 2. So, we have equation A and equation B. For equation A, we need to find the value of K. So, the formula, since we are dealing with spring, and that is simple harmonic motion, so the formula would be F is equal to Kx. Okay. So, bakit siya positive? Later on, you will understand why. Okay. So, from the given or the equation, hindi natin masosolve yung ating hinahanap. So, we need to derive this one. Deriving the formula, it will become K is equal to F over X or the displacement. For B, the formula is the formula in frequency of the simple harmonic motion. And the formula is F is equal to 2 pi over square root of K over M. K. So now we have two solutions here since we have two equations. Before we proceed with the equation, take a look on the equation A. The equation here is K is equal to F over X. We have the value of X, pero wala tayong value ng F. Paano kaya natin isosolve yan kung wala tayong value ng F, no? So, as you can see, we have the value of mass. Remember the Newton's second law of motion, F is equal to mass multiplied to acceleration, or F is equal to ma. So, yung mass natin na yan, i-multiply natin siya sa acceleration. Since ang spring natin ay nakasuspended, so nakapaganyan siya, vertical position, so merong force, external force na nakakaapekto dun sa spring. And that force is affected by the acceleration due to gravity. To calculate the value of force, we need to multiply the mass to the acceleration due to gravity. So, magkakaroon tayo ng force. So, let us multiply 2.5. That is the value of the mass. Multiplied to the acceleration due to gravity kasi nakasuspended ang ating spring. So, that is 9.8 meter per second squared. So, multiplying this, the unit for our force would be 24.5 Newton. Since we have the value of the force and we have the value of the x or displacement, which is 0.05, we can now proceed with solution A. We just have to substitute this given to the equation. So, let us do this. So, we have K is equal to value of a force na sinolve natin, that is 24.5 Newton. And the value of our displacement, which is 0.05 meter. Doing the math, the answer for letter A would be 490 Newton per meter. So, as simple as that. Now, we are done with the solution A and the answer for A. Now, let us proceed with B. So, dito naman, we have the value of our K. We know this one, 490. We have the value of our M, the mass. Okay, so we can now compute for the value of our frequency. So, substitute lang natin. So, we have 1 over 2 pi square root of K, which is 490 Newton meter, na solve na natin. And we have 2.5, that is the value of the mass. So, since we're dealing with frequency, hindi ko na nilagay dito yung unit kasi kailangan pa nating ilagay itong unit nitong pi rad. So, alam naman natin that frequency, the unit would be hertz. So, in this case, the answer would be P is equal to frequency 2.2 hertz. So, napakadali lang ng ating problem. So, ganun lang siya kadaling isagot. No? Remember, no, sa equation kasi natin, sinolve muna natin yung F. So, paano natin na-solve yung F? By having the Newton's second law of motion that the external force can be calculated by multiplying the mass to acceleration due to gravity. Bakit natin ginamit yung acceleration due to gravity? Because the spring is suspended, so it was affected by the force of gravity. Hinihila ngayon yung mass ng object. Kaya yun yung nakakadagdag para ma-stretch yung spring. So, that is the external force. Kaya, positive ang ginamit natin dito. I hope you understand this lesson. So, that is the end of our problem. So, if you have question, just message me in my Facebook account or in our Google Classroom or in our Septo LMS for questions. And then, thank you everyone for the evaluation. It can be found on your Google Classroom. Maybe I will put it on the Septo LMS, but I will assure you that you can find the learning activities for this video presentation in the Google Classroom. I hope you enjoy our class. Thank you everyone.